Okay, so now we're going to look at how to do subatomic particle calculations. Remember that anytime you want to start one of these activities that you look at the target for the day and make sure that you understand it. If someone asks you what you're doing, you should point to the target or be able to tell them the target. All right, so um, things that we are working on today. First, you're going to watch a short expert excerpt of video. It may say tritium. It also may say how Dr. Octavius became Doc Ock or Dr. Octopus. It's an excerpt from Spider-Man 2. Make sure that when you're watching the video that you don't just pay attention to the action, but you listen to the explanation that Dr. Ott gets at the beginning about how this whole experiment even works and focus on what the chemical is that he is using in order to fuel the fusion reactor. All right, so to do the activity for today, you definitely need a periodic table. So go ahead and make sure that you have yours from inside your notebook. Hopefully it looks like this. Um, and we'll need that for today. The premise of everything for today is that an atom is the simplest form of an element, okay? That it's neutral, which is the same as saying has no charge or zero charge, okay? Also remember that this is made up of protons, it's made up of neutrons, and it's made up of electrons. We learned all of that from our simulation. So now let's talk about a reminder about where these particles are and how we symbolize them. Protons usually have the symbol of a P with a little plus. The plus is up high in the air like Superman. It is called a superscript. Electrons looks very similar except there's a minus, and neutrons has a zero. So protons have a +1 charge. Their mass is 1, and the location is in the nucleus. Okay. Electrons have a charge of -1. Their mass is 0. Well, almost 0. It's like 3 decimal places out, so we consider it negligible. The location is going to be around the outside of the atom. It is not in the nucleus. Neutrons have no charge. They have a mass of 1. They're actually a little bit bigger than a proton, and their location is in the nucleus. Also, to understand today's activity, you have to be reminded that isotopes are different forms of the same atom. Or I should say, same elements, not the same atom. They have the same protons and the same electrons, but different neutrons. And having different neutrons means that the mass will change because this is changing. How many it has changes. Therefore, the mass is also going to change. So let's look at a couple of examples. First, let's focus on a simple example of oxygen. Okay. Now, if I look at the periodic table, my atomic number is going to come directly from the periodic table. The atomic number from periodic table, okay, and it's going to be a whole number, okay? So if I look at the periodic table for oxygen, oxygen has the symbol of O, but even if I didn't have that, I had the spelling, okay? So oxygen symbol is O, and the atomic number is this whole number that is right there. So on my periodic table, I'm going to write that the whole number is 8. I want you to be reminded that this whole number or this number is always a whole number. Okay. All right. Mass number. We're going to skip that for a second. We are going to move to the number of protons because the number of protons is always the same as the atomic number. So if I know the number of protons, then I know the atomic number. Okay. So this is the whole number from the periodic table. And it's going to be that whole number. So if I have this one, I can automatically fill in this one. So the answer is going to be 8. Now, atoms are neutral. That means it has the same number of pluses as it does minuses. Okay, so we're going to skip down a little bit and we're going to go to the number of electrons. Okay, this number is going to be the same as the number of protons because the number of protons has to equal the number of electrons so that your pluses and your minuses add up to be 0. So if I have 8 of these, if I have 8 protons, I have to have 8 electrons. So I want it with 8 pluses and 8 minuses, and they cancel. So my number of electrons has to be 8. All right, my mass number. I'm going to look, since it just says oxygen, that means most oxygen, right? So I'm going to look at the periodic table. I'm going to look for the average atomic mass. The average atomic mass is the decimal number, okay? So I'm going to write up here just so that you are aware and you can follow my thinking here that the average atomic mass is the decimal number on the periodic table. Okay. So if I take the decimal number under oxygen, it is 15.999. So 15.999. Okay. To get the mass number, we're going to round that number. Okay. We're going to round that number. So this number is found. This number is going to be 16. And it's found by rounding the average atomic mass. Okay. And again, this is from the periodic table. So this number, atomic number, comes from the periodic table. Mass number comes from the periodic table. Okay. Protons comes from the periodic table. Electrons comes from the periodic table. So in all of these calculations, you need the periodic table. The most complicated one so far is this average atomic mass because you had to round it. Well, now we have the number of neutrons. It turns out that the number of neutrons mass is equal to protons plus neutrons. Okay, that means if my mass number is 16, that's going to be equal to 8 plus n. So n has to equal 8. In this atom, all of them are the same. It is not usually the same. Okay, it is not usually the same. It is sometimes. Well, a lot of atoms are the same. A lot of isotopes are the same, but I don't want you to assume that they're always the same. So from the element name, you can calculate the number of you can find the atomic number. You can use the atomic number to figure out the number of protons. The number of protons is equal to the number of neutrons. Then you look back at the periodic table to find the average atomic mass. And the average atomic mass is the mass number. And then the mass number can be used in this equation in order to figure out the number of neutrons. If this confused you at all, please watch it again step by step and see Miss Solomon or Mr. Williams for help.